Alright guys, let's look at some review questions for the test on logic and probability. So number one, we've got these two statements: students work hard, students will succeed. We need to write the following proposition in symbols. If students do not work hard, as soon as I see the if, I know that I'm dealing with one of these arrows situations. So, and then the if is the part that comes before the arrow. Students do not work hard, that's not P. Then they will not succeed, that is not Q. Part B, complete the following truth table relating to the statement made in Part A. So we're trying to find out whether this statement in Part A is true, so we first need to figure out what not P is, then not Q, and then we'll figure out the entire implication. Right, so not P is the opposite, false, false, true, true. Not Q is the opposite of Q, false, true. And then when does, we've got not P pointing to not Q. The only time this will be false is when T points to F. So that's the only false. Everything else must be true. Number two. The propositions P and Q are defined like that. So Part A. Write in symbols, neither Jones nor Smith passed the course. What does this mean? It means that Jones did not pass, and at the same time Smith did not pass. Neither one of them passed. Not both, not one, not the other, none of them. So one way we could say this is that Jones did not pass the course, and at the same time Smith did not pass the course. That'd be one way I could say it. Or another way I could say it, and you'll see this actually from De Morgan's law, as it turns out, but we could say it is not the case that Jones or Smith passed the course. Because we don't want either one of them nor both to have passed, then we can simply, and we know that the or word is what includes either one of them or both, and we can simply say it is not the case that Jones or Smith passed the course. Therefore, it is not the case that Jones or Smith passed the course. Alright, part double I. It is not, oh gosh, well, will you look at that? That's exactly what I just told you. It is not the case that Jones and Smith both, I honestly did not read that before saying it. So you can see how consistent and predictable the language is. Once you've seen enough of these questions, you know exactly word for word how it's going to be. And so I've now answered part I and part double I. Obviously, they mean the same thing because of De Morgan's law. Part B, here's the truth table. So, not P. And now we need to combine this in an OR with Q, so I'm combining these two with an OR. With an OR, that's very inclusive, and so as long as I've got at least one true, I'm okay. The only time an OR is ever going to be false is when I've got false, false. And there's your truth table. Number three. So, two propositions have been given. We need to write this one in symbols. You have understood this topic, that is P, or you will not be able to do this question. A fairly accurate statement, it seems. Part B, explain in words only what this represents. Alright, so we've got P and not Q. So, you have understood this topic, and you are not able to do this question. And then I've got an arrow, and the arrow shows me then that in fact everything I've written so far is part of an if clause, and then everything that comes after the arrow is part of a then clause. Then not P, then you have not understood this topic. Okay. Number four. Alex is from Uruguay, Alex is a scientist, Alex plays the flute. Write each of these arguments in symbols. We have to write an argument. So remember, an argument is something that includes this. So it's going to be a whole bunch of phrases, sometimes only a couple of them, or sometimes maybe even only one of them, but it's going to be implying a conclusion. Alright, so if Alex is not a scientist, alright, if Alex is not a scientist, so that's not Q, then he is not from Uruguay, so not P. Part II, if Alex is a scientist, then he is either from Uruguay or plays the flute. Now don't get fooled by this word either. It has to say exactly one of Uruguay or playing the flute, or it will have to say but not both, if it means that not both can occur. But this doesn't say either of those phrases. The either is just kind of an extra word which is tied into the or. So this actually could include both. That he is either from Uruguay or he plays the flute. So this is not the exclusive or with the line on the bottom, because it doesn't say but not both, and it doesn't say exactly one of. So we assume it means that both could in fact occur here, like a regular or. Part B, let's write this argument into words. So not are, so, and then we're going to end up with an arrow. So if Alex does not play the flute, then, then it is not the case that Alex is a scientist or Alex is from Uruguay. I could write it like that, or some of you commented in class that maybe you could use De Morgan's law here and end up with not Q. And you remember when the negation is distributing to a set of parentheses, the symbol in the middle flips upside down. So now the negation is on Q and P, and the middle sign is upside down. One of De Morgan's laws. So then I guess we could read this as not Q and not P. So Alex is not a scientist, and Alex is not from Uruguay. So then Alex is not a scientist, and he is not from Uruguay. Which is the same thing as saying it's not the case that he is from Uruguay or a scientist. So either way, whether you use De Morgan's law or not, you should get credit. But you'll notice that this one I flipped into an and when I distributed the not to both clauses. Now we need to construct a truth table for the argument in part B, and we want to see whether the argument is logically valid. So we know that the argument will be logically valid if I have a tautology. I will only have a tautology if all of the ones in the final column are true. Okay, so here we go. They've already given us not are. We need to add on a few other things. We need to figure out what Q and P is. Sorry, Q or P. And then we'll need to negate that column. And then we'll see what happens when not are is pointing to that new column we've just created. So let's look at Q or P. So we know that an or is true any time that we have at least one true. And so in fact the only time that we ever have both falses is at the very bottom in the last two rows. So true, 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 false, false. Alright, and then we need to negate this column. So now it's going to become almost entirely false, with a couple of trues at the bottom. Now we want to see what happens when not are points to this new column I've just created. So here's not are. We've got false pointing to false. So this is kind of the biggie right here, the implication that we're looking at though of the overall statement, the argument. So we've got F pointing to F. Well, that's true. T pointing to F, false. You know what? We don't even need to continue. This argument is clearly not logically valid because I have at least one false that has appeared in my final column. Now, I guess you could complete the column just in case, there's the smallest of chances, I guess, that they might deduct a mark for not completing the column, but I think at this stage, as soon as you've got one false, and in this case we actually end up with 3 falses, then of course the argument is not logically valid. And you should probably explain why, because I have at least one false in the final column. Number 5. We need to complete this truth table. So we've got first P and Q. So that's, the AND is only going to be true if both are true. In every other case it's false because I have at least one false. Let's negate that false, true, true, true. Alright, let's stick in together now not P or not Q. Oops, that one should be true, shouldn't it? With an OR, as long as I have at least one true. Alright, now, are these compound propositions equivalent? So we're looking at this one, and we're looking at this one. And indeed, we do get the exact same truth table structure. So we can say yes, and you probably would be wise to say why, but looking at 4 marks, it looks to me like that's 1 mark, 2 marks, 3 marks, and 4 marks. So my guess is saying why wouldn't be necessary, but at any rate, I would probably say because the truth table columns have the same structure, or are identical, or something like that. Okay? Alright. Consider Amy eats sweets and Amy goes swimming. So we need to write this in symbolic form. Amy either eats sweets. Okay, remember, don't be fooled by the either. That's kind of an irrelevant word. Amy eats sweets or goes swimming. So eats sweets or goes swimming. But not both. That's the one where we stick the line on the bottom, because we had that key phrase. Okay, alright, we'll continue in the next video with the next set of questions solutions.